This is SpaceTime, Series 20, Episode 98. Coming up on SpaceTime, Juno probes the depths of Jupiter's Great Red Spot, life discovered living on just thin air, and claims that the red planet Mars does have a protective magnetosphere after all. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Data collected by NASA's Juno spacecraft during its first close flyby over Jupiter's Great Red Spot back in July has confirmed that the iconic feature penetrates deep below the clouds. The findings were announced at the annual American Geophysical meeting in New Orleans. Juno's principal investigator Scott Bolton from the Southwest Research Institute in San Antonio, Texas, says Jupiter's Great Red Spot has roots which penetrate some 300 kilometers deep into the planet's atmosphere. The data comes from Juno's microwave radiometer, which compared deep below the Jovian clouds. Jupiter's Great Red Spot is a giant oval of crimson-coloured clouds in Jupiter's southern hemisphere. These clouds race counterclockwise around the oval's perimeter, with wind speeds greater than any storm on Earth. Measuring some 16,000 kilometres in width as of the 3rd of April 2017, the Great Red Spot is some 1.3 times as wide as Earth. Juno's findings mean the Great Red Spot's roots go some 100 times deeper than Earth's oceans and are warmer at the base than they are at the top. Winds are associated with differences in temperature, and the warmth of the spot's base explains the ferocious winds seen at the top of the atmosphere. The future of the Great Red Spot is still very much up for debate. While the storm's been monitored ever since 1830, it's possibly existed for more than 350 years. Back in the 19th century, the Great Red Spot was almost 3 times as wide as the Earth. But in more recent times, it appears to be diminishing in size, as measured both by Earth-based telescopes and spacecraft. At the time NASA's Voyagers 1 and 2 sped past Jupiter in 1979, the Great Red Spot was still twice Earth's diameter. But today's measurements by Earth-based telescopes indicate that the oval Juno flew over has diminished in width by about 1/3 and height by at least 1/8. Since Voyager times. Juno's also detected a new radiation zone just above the giant planet's atmosphere, near the equator. The zone includes energetic hydrogen, oxygen and sulfur ions, all moving at almost the speed of light. Scientists only found out about these new radiation zones because of Juno's unique orbit around Jupiter. In order to avoid the worst of Jupiter's radiation, Juno flies to within a few thousand kilometers above the giant planet's swirling cloud tops. Consequently, the spacecraft literally flew through these new radiation zones. The new zones were identified by JEDI, the Jupiter Energetic Particle Detector instrument. The particles are believed to be derived from energetic neutral atoms, fast-moving with no electric charge, that are created in the gas around the 2 Jovian Galilean moons, Io and Europa. These neutral atoms then become ions as their electrons are stripped away by Jupiter's upper atmosphere. Juno also found signatures of a high-energy heavy ion population within the inner edges of Jupiter's relativistic electron radiation belt, a region dominated by electrons moving close to the speed of light. The signatures are observed during Juno's high-latitude encounters with the electron belt in regions never previously explored by spacecraft. The origin and exact species of these particles have not yet been fully understood. Juno's Stellar Reference Unit star camera detects the signatures of this population as extremely high-noise signatures in images collected by the mission's radiation monitoring investigation. Juno has just completed its 9th science orbit over Jupiter. Juno was launched on an Atlas V rocket back on August 5, 2011 from the Cape Canaveral Air Force Base in Florida. And it achieved orbit insertion around Jupiter almost 5 years later on July 4, 2016. During its mission of exploration, Juno swoops low, soaring over the giant planet's cloud tops as close as 3,400 kilometers. These highly elongated orbits are designed to avoid as much of Jupiter's intense radiation zones as possible. During these flybys, Juno probes beneath the obscuring cloud cover in order to study the planet's structure and composition, as well as its winds, atmosphere, aurora and magnetosphere, in order to learn more about the evolution of the gas giant, this king of planets in our solar system, and consequently learn more about the evolution of the rest of the solar system as a result. You're listening to SpaceTime. I'm Stuart Gary. scientists have discovered microbes that literally live on thin air. The bacteria were discovered in Antarctica, scavenging hydrogen, carbon monoxide and carbon dioxide from the air in order to stay alive in the extreme conditions. The findings, reported in the journal Nature, have serious implications for the search for life on other planets, suggesting that extraterrestrial microbes could also rely on trace atmospheric gases for survival. The study's lead author, Associate Professor Belinda Ferrari from the University of New South Wales, says this new understanding about how life can exist in physically extreme and nutrient-starved environments like Antarctica opens up the possibility of atmospheric gases supporting life on other planets. Antarctica is one of the most extreme environments on Earth. Yet these cold, dark and dry desert regions are home to a surprisingly rich diversity of microbial communities. The big question is, how can the microbes survive where there's little water, where the soils are very low in organic carbon, and there's very little capacity to produce energy from the sun through photosynthesis during the long winter darkness? Ferrari and colleagues found that these Antarctic microbes have evolved mechanisms to live on air instead. In fact, they get most of the energy and carbon they need simply by scavenging trace atmospheric gases, including hydrogen and carbon monoxide. The authors found the microbes in 2 soil samples collected from coastal ice-free sites in different regions of eastern Antarctica. One was Robinson Ridge, 10 kilometres from Casey Station in Wilkes Land. The other was Adams Flat, 242 kilometres from Davis Station in Princess Elizabeth Land. Both these areas are pristine polar deserts, devoid of any vascular plants. The researchers studied the microbial DNA in the surface soil from both sites and were able to reconstruct the genomes of 23 of the microbes that live there, including some of the first genomes of 2 groups of previously unknown bacteria called WPS2 and AD3. They found the dominant species in the soils had genes which give them a high affinity for hydrogen and carbon monoxide, allowing them to remove the trace gases from the air at a high enough rate to sustain their predicted energy needs and support primary production. Ferrari says more research is needed to see if this novel use of atmospheric gases as an alternative energy source is more widespread in Antarctica and elsewhere.
Over the last couple of years, we've been looking at an area that was high in some novel bacteria that no one knew anything about. And so we did some genomics and combined that with biochemical studies and found that these bacteria look to be surviving and thriving in those couple of areas because they're growing on hydrogen, carbon monoxide and carbon dioxide gas in the atmosphere.
So they're literally filtering the atmosphere in order to get the nutrients they need to survive?
Yeah, pretty much. And it's really low levels as well. So it's down to below atmospheric levels. We've seen them pull the hydrogen to below atmospheric levels. So really, really low levels that they're using.
Is that unusual?
It's not usual. There's been a couple of studies where a particular 1 or 2 isolates have been shown to be able to do this. So not a lot, so a couple of strains that people have had. But this is the first time where it looks like a whole ecosystem is actually being fueled by that process. So it's sort of the primary production process in that environment. So that's what's new. It's a whole ecosystem.
You looked at 2 specific areas in Antarctica.
So those locations are in eastern Antarctica. They're quite a distance away from Australia's scientific stations. So they're very underexplored. There hasn't been a lot of investigations looking at what type of organisms live there, and they're really, really barren. So there's no vascular plants, there's some little invertebrates and things, and it's really just rock. Hardly any nutrients and not a lot of organisms there at all.
When people hear about Antarctica, they normally don't think of the desert, but that's really what you're in, isn't it?
Yeah, it's pretty much a desert, nothing else there. Even humans at a couple of these sites, they visit it not very often at all. So these samples for one of the sites we got back in 2005, and I've been trying to get back there to get some more soils, but it's quite hard because it's far away from the station. So they're really unexplored deserts, polar deserts.
How concerned are you about the impact that the research has on the ecosystem there?
Well, what I'm hoping is it's going to strengthen the chance for us to get back down there again and resample, because it has been sort of 12 years at one of the locations. I'm hoping that they're still there. And what we're now going to look at in the future is to make sure things like environmental change won't affect them as things warm up. And so that's part of where we're going to go in the future, just make sure they're still there as well. and see what's happening.
Antarctica is such a delicate ecosystem as it is now, and it's so easily susceptible to even what would be considered very minute changes to the environment.
Yeah, I think it is, and I think that's why this study in the future will be good, because the site hasn't been touched where we got the original sample from for so many years. We're hoping to go back and maybe we will be able to detect any change that might have happened over the last decade, and that will give us a bit of an idea of how sensitive it is. I think these bacteria will be quite sensitive because any warming, that might change the fact that at this stage there's very low levels of organisms that carry out photosynthesis. So maybe as it warms up, those guys might come back and outcompete these trace gas scavengers. So it's definitely going to be interesting.
That's what we're calling them, trace gas scavengers?
Yeah. We're trying to work out what to call them. There has been a number of studies, so scavenging of the hydrogen gas, that's something that a lot of bacteria can do just to survive as well. So in a lot of aerobic soils, they've been reported for a number of years, and they've been calling them trace gas scavengers. So the difference here is they're producing enough energy from that scavenging to also fit carbon. So that's something that changed the way we looked at these scavengers.
Are they bacteria or archaea?
Bacteria.
And what's the difference between the two?
They have different layers, like the cell walls are made up of different things. They are quite similar, but it's just parts of the cell layer and other bits and pieces that are a little bit different. There are some archaea in this environment, but just not a lot that we've looked at. But at this stage, it's mostly bacteria, actinobacteria, that are quite well known. So they're some of the bacteria that produce a lot of your antibiotics and things. They have this capacity, as well as two novel phyla that we knew nothing about. And you never know, there's probably more out there. So that we're hoping to look at a lot of different desert environments now to see if they can do this as well.
And what are the implications for life beyond Earth?
So our study provides first evidence that organisms can live off trace gases, and the fact that there are trace gases on a lot of other planets gives the idea that there potentially is some form of life on other planets greater potential.
That's Associate Professor Belinda Ferrari from the University of New South Wales. I'm Stuart Gary. This is SpaceTime. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at SpaceTime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/SpaceTime with Stuart Gary. A new study claims the Martian atmosphere is well protected from the effects of the solar wind despite the absence of a global Earth-like magnetic field. The new research, reported in the journal Geophysical Research Letters, is based on measurements from the Aspera-3 particle instrument aboard the European Space Agency's Mars Express spacecraft. Present-day Mars is a freeze-dried desert with less than 1% of Earth's atmospheric pressure at the surface. However, the red planet was once a warm, wet world, with liquid water streams and rivers flowing into lakes and oceans. And like Earth, Mars once had a magnetosphere, a vast comet-shaped bubble-like magnetic field generated by its liquid iron core acting as a geodynamo. These magnetic fields help to protect the planet's atmosphere from being eroded into space by the constant blast of the solar wind from the sun. However, being just a third the size and mass of the Earth meant Mars cooled down very quickly, causing its molten core to begin solidifying, in the process shutting down its protective magnetic field within the first billion years of the planet's formation. A common hypothesis maintains that the solar wind over time has eroded the early Martian atmosphere, causing the planet's hydrological cycle to collapse. However, it seems it's not that simple. While Mars now lacks Earth's geodynamo-driven magnetic field, the solar wind instead induces currents in the ionized upper Martian atmosphere, creating a sort of induced magnetosphere. The study's author, Robin Ramstad, from the Swedish Institute of Space Physics and Umeå University, says the new findings contradict earlier hypotheses that this induced magnetosphere would be insufficient to protect the Martian atmosphere. Ramstad compared measurements of the ion escape under varying solar wind conditions and levels of ionizing extreme ultraviolet radiation. The results showed that the solar wind has a comparatively small effect on the ion escape rate, which instead mainly depends on the extreme ultraviolet radiation. This, therefore, has a really major effect on estimations of the total amount of atmosphere that's escaped from Mars into space. Ramstad says that despite the stronger solar wind and extreme ultraviolet radiation levels under the early sun, ion escape still can't explain more than 0.006 bar of atmospheric pressure lost over the course of 3.9 billion years. He says even the upper estimates of 0.01 bar is an insignificant amount in comparison to the atmosphere required to maintain a sufficiently strong greenhouse effect, which is at very least 1 bar or more according to climate models. The results show that a stronger solar wind mainly accelerates particles already escaping the planet's gravity, but does not increase the actual ion escape rate. And contrary to previous assumptions, the induced magnetosphere is also shown to protect the bulk of the Martian ionosphere from solar wind energy transfer. This is Space Time. I'm Stuart Gary. Okay, let's take a quick break from the program so I can tell you about our new deal. We have a great offer for listeners of Space Time. Audible's offering a free audiobook download and a free 30-day trial. There's a massive range to choose from, including bestsellers such as Breaking the Chains of Gravity. That's the story of spaceflight before NASA. And there's Astrophysics for People in a Hurry by Neil deGrasse Tyson. And Endurance, A Year in Space, a lifetime of discovery by astronaut Scott Kelly as he documents his record-breaking achievements aboard the International Space Station. So many great books, no matter what your taste. In fact, over 180,000 titles to choose from. And there's no need to rush. Not only do we give you a free book, but you can have a 30-day free trial to browse to your heart's content. To download your free audiobook today, go to audibletrial.com/spacetime. Again, that's audibletrial.com/spacetime for your free audiobook. Or just click on the link at spacetimewithstuartgary.com or in the show notes. And now, it's back to the program. Well, this time of the year we couldn't really end the show without acknowledging the holiday season, and so we bring you the Skeptic's Guide to Christmas. The scientific method involves observation, hypothesis, experimentation, analysis, and conclusion. Science is all about critical thinking. It's a search for the truth. Don't just take someone's word for it. Test the claim, see if it's factual and stands up, or if it's just a great steaming pile of woo. That's what skepticism is all about. It's a search for the truth. And remember, scientific facts don't care if you believe them or not. Well, as any fan of the television sitcom Big Bang Theory knows, Christmas, according to Dr. Sheldon Cooper, originated not as a celebration of the birth of Christ, but as the ancient Roman pagan festival of Saturnalia. Saturnalia honours the pagan god Saturn and marks the Northern Hemisphere winter solstice, which occurs each year around December the 22nd. Saturnalia is celebrated because the days start to get longer and eventually warmer. The week-long holiday was celebrated with a sacrifice in the Temple of Saturn in the Roman Forum. There was a public banquet, followed by an exchange of gifts among friends and family, as well as heaps of partying and carnival activities. The conversion of the Emperor Constantine to Christianity in 312 began imperial patronage of the Christian Church. But Saturnalia continued to be celebrated, together with another Roman holiday, Sol Invictus, held on December the 25th to celebrate the birthday of the invincible Roman sun god. Now that's important because that happened to be the cult in which Constantine was raised. And despite his conversion to Christianity, Constantine always remained a true believer. Cancelling Saturnalia would have been unthinkable, so instead Christian Rome converted it to a Christian holy day, marking the birth of Jesus. As well as the Roman traditions, rites and rituals from the Vikings and Anglo-Saxons have also survived to become part of the modern celebration of Christmas. The tradition of kissing under the mistletoe is sometimes attributed to the Viking goddess of love and marriage, Frigg, whose legend is associated with the plant. In fact, the pre-Christian Germanic peoples, including the Anglo-Saxons and the Norse, celebrated a midwinter festival called Yule, leading to the modern-day English Yule, a synonym for Christmas. The Christmas tree or Weihnachtsbaum is another German tradition, which itself is rooted in even older traditions related to the decorations made out of evergreen plants, a custom dating back to early Jewish traditions. Hanukkah, the Jewish festival of lights, also occurs around the same time of year, marking the rededication of the Second Jewish Temple in Jerusalem about 160 years before Jesus was born. The tradition of adding lights to the Christmas tree is attributed to Protestant Christian reformer Martin Luther, who is said to have first added lighted candles to an evergreen tree, symbolising Jesus being the light of the world, the statement he proclaimed while visiting the Jewish temple in Jerusalem and seeing the Hanukkah lights. Aran Segev, president of Australian Skeptics, is a regular contributor to the SpaceTime program, and he joins us now with a Skeptic's Guide to Christmas.
Let's just assume that the biblical Jesus did exist and that related biblical accounts about his birth are also historic. So the first question is, what evidence we have for the birth date of Jesus? And the answer fluctuates depending on who's answering, but very few, even among devout Christians, argue that there is compelling indication as to when Jesus was born. There are some Christian claims that there is indirect evidence based on the birth date of John the Baptist that Jesus was born around September, but that's a bit of a tenuous connection and it's based on a very large number of assumptions, and as far as I can tell, it isn't widely accepted.
Yeah, I thought it was around April that he was born, so your information is September.
What my understanding is that they somehow calculated that John the Baptist or something like that. There are also many who claim that the shepherds mentioned in the Bible would not have been out in the field in late December, which is indeed rather cold in Judea and often it rains. I don't think I would want to spend the night out in Judea in December. However, that does not mean that shepherds wouldn't be there. But again, it's not as strong. It definitely doesn't strengthen the idea that Jesus was born around that time. Christmas was first celebrated on the current date in the middle of the 4th century. By then, more than 300 years will have passed since Jesus died. It is very unlikely that people knew his birthday for 300 years and didn't celebrate it. And then all of a sudden, 300 years later, they started celebrating it and they got the date correct. That's probably not right. So if Jesus wasn't born on the 25th of December, why is Christmas celebrated on that date?
So Isaac Newton's birthday, no?
Absolutely. We could call it Newton Mass from now on, but I think maybe today we will focus on why it is celebrated on that date. And we do know for sure that it was not celebrated on the 25th of December because of Newton, because Christmas was first celebrated before Newton was born, quite a long time before Newton was born. So a strong hint as to why it is the 25th of December is the fact that the date is only a couple of days after the winter solstice, which is, of course, as listeners to this program will probably know, is the shortest day of the year in the northern hemisphere, of course. And at a time before electricity, knowing the days are starting to lengthen was definitely a cause for celebration. And indeed, there is evidence that many cultures that had festivals around that time, often revolving around light or fire, things that indicate energy and renewal. For example, the Hopi Indians celebrate a festival called Soyal around the winter solstice. Dongji is celebrated in China. And even the Jewish holiday of Hanukkah is celebrated in late November to late December. The date changes according to the Jewish calendar. And while the origins of the holiday are definitely not related to the solstice, a lot of the Hanukkah traditions are very similar to other solstice holidays. Fire, light, a lot of people know that Hanukkah is called the Festival of Lights.
But doesn't the Roman pagan festival of Saturnalia have a role to play in all this?
Absolutely. This is actually the most important part. The Roman Emperor Constantine, who was the first Christian emperor, ruled at the time the first Christmas celebrations, and it is very likely that he simply wanted to give Christian flavor to common festivals already celebrated in his empire. So it's worth noting that religious traditions that are based on older cultures are common. Perhaps the most famous example is Noah's flood, which is blatantly plagiarized from the much earlier Sumerian epic of Gilgamesh. So there is no evidence as to when Jesus was born, some weak evidence that late December is unlikely, and a lot of evidence that borrowing from other cultures is very likely the reason for the choice of the date. When put that way, it's easy to see that it's unlikely that Mary's boy child was really born on Christmas Day. So what do we do with that? Well, my suggestion is to decorate your houses, buy presents, and celebrate with family and friends, because any reason is a good enough excuse for that, and even skeptics don't need evidence to agree.
That's Aran Segev, president of Australian Skeptics. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from SpaceTimeWithStuartGary.com, or from your favourite podcast download provider. SpaceTime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., around the world on TuneIn Radio, and as part of Virgin Australia's in-flight entertainment. If you want more space time, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Today's episode of Spacetime was brought to you by Audible.com. Help support the show and get your first book for free, plus a 30-day free trial. Use the link www.audibletrial.com/spacetime. That's www.audibletrial.com/spacetime for your free audiobook.